Hey everybody, this is going to be the introduction for V-Ray for Rhino, specifically looking at the project that we're going to be doing on the Elm and Liberty Street site. So in this case, I have imported the Barcelona Pavilion and placed it on our site, and it fits rather nicely actually. It's actually not a bad design for the site to begin with. Kind of funny how that works out. Now for you can either import the precedent model that you constructed in assignment 5 or the design that you came up with for the public restroom that you did in Studio. We're not quite far enough along in the Studio project to actually make that into a renderable project, although you can use the techniques that we cover here at a later point to do that. So just use one of those two projects, whichever is fine, and import it like we have here. I still have all of my layers and everything that I used to build the model, keeping everything separate as much as possible. I also have a three-dimensional topographic surface, and that'll be important if you decide to go with a section perspective, so you can actually get a realistic look at the site drop-off that happens, because there is a pretty sizable amount of elevation difference between the front of the site and the rear. So I believe this point here and that point there are about 8 feet different, which is, pretty decent across the length of this thing. Now the whole site is 270 feet long, so, it's a fairly gradual slope despite that. But still, it is a noticeable difference and one that you would pick up in a section perspective. So if you haven't constructed a three-dimensional site using topography, I posted a video maybe a week or two ago that you can follow that shows you how to do that, and that's a good first step. The other thing you'll want to do is make sure you have all the buildings set up correctly. Now for Thea, I had to actually import the buildings and not actually use them in the work session. I've actually not tried it in V-Ray yet, although I will post a note at the bottom of this video whether or not work sessions work or if inserted block geometry works. These are all imported directly, so you can see here they're actual live geometry that I can edit. All the line work is line work sitting in the model. And again, for Thea, I had to do this. I haven't tested it both ways in V-Ray, but I will get back to you on that as to which one works better and which is best practice. Anyways, so the first thing I'm going to do is just cover general V-Ray. So there is a toolbar up here that's for V-Ray. The blue one on the right is for Thea. I'm not covering that in this video. If you do not have the toolbar, there's a few things you should check. First of all, your current renderer under render should be set to V-Ray. I have both installed, but we're only going to be doing V-Ray. Generally speaking, too, it's better not to have multiple renderers installed. They do sometimes conflict with each other. I haven't had many issues. I've had some slight glitches and errors with the software, but nothing too major. And I can't necessarily say whether it's because of the fact that I have 2 renderers installed or not, but it is something generally good to avoid. If you don't have the toolbar, you can right-click in your toolbar and you can do show toolbars and go down to V-Ray down here somewhere and just make sure that it is appearing. I do have it appear, so the first tool is going to be your most useful. This is the V-Ray asset editor, and this is basically where every setting lives in the entirety of V-Ray. It actually pretty much does all the functionality of all the other components in the toolbar, just in this sort of one pop-up window. So there's a sort of side that you can add. These little arrows will allow you to open the sides. I'm going to first go to the gear that we see here and just kind of go through the general settings. Now, what makes V-Ray complicated is, if I were to open up all these fields, you can start to see that there's a lot of options, and these are just the sort of visible fields. And there's a lot of fields within fields that you have to sort of select too. But this is kind of where the complication of V-Ray exists, because how many settings there are to adjust. And if you really want to master V-Ray, you probably don't need to know every single thing that's going on here. I certainly don't know every single thing. I know a good bit of them, but not everything. But getting a general familiarity with where things are is going to be helpful in the long term. So I'm going to go over some of these now. But it used to be in V-Ray 2, which it's been a couple years now since they had V-Ray 2, you could open everything in a linear line and just scroll through the whole thing, and it just kept scrolling and scrolling and scrolling. It was pretty great to see. But now they have a different organization. So the very first thing we have here is the renderer. So we have a few options here. So I am using the current V-Ray 4.0 beta, although it should look essentially the same as a 3.0 version. I compared the two back to back and found only minor differences. So it shouldn't really make a difference. Like in this case, you might not have RTX as an option in 3.0, whereas I do. Doesn't really matter. I'm not going to be using it anyways. But just so you know, if there are minor differences, that does happen. V-Ray does update fairly often, and when they do update, they often change the location of things. Again, I checked through in the current version, 3.0 versus this seemed to not have changed too much as far as locations go, so it should work out fine. So the first thing you have is this toggle here. Well, we have CPU, CUDA, and RTX. This is essentially whether or not you want to render on your CPU, which is your central processing unit. CUDA in this case is my GPU, and RTX is also my GPU. I believe V-Ray may not be able to run on an AMD GPU, and there's essentially two companies in the world that make GPUs, AMD and NVIDIA. And I believe V-Ray only supports CUDA, which is NVIDIA. So this may not be an option for you anyways, depending on what particular hardware you have. But anyways, it doesn't matter too much. For this example, I'm going to stick with CPU. First up, we have interactive. And all this does is that while you're rendering, as you make changes in your model, changes the textures and lighting, all that kind of stuff, the render is constantly updating. So it's not rendering a static image, it's constantly updating with whatever changes you make. This is really useful when first setting up your rendering, testing lighting, creating those materials and everything, because you get real-time feedback as to what you are looking at. You can toggle it off, and it will open up another setting here, which is progressive, which is essentially the same rendering process, but isn't interactive. And you can toggle that off to go to what is the sort of standard renderer. And this is what you'll want to do when you want to make your final version of a rendering. We have a quality setting here. So I mentioned in a previous video that one of the differences that you often see between a bias and non-bias renderer, and this is a bias renderer, is that you do have a quality setting, whereas a non-bias renderer doesn't typically have that. A non-bias renderer typically just allows more time or a higher number of samples per pixel to get to a higher level of quality, but isn't sort of a set output from the beginning necessarily. So in this case, we do have them. So in general, when testing, I tend to leave it at medium. When going for a sort of final production render, I tend to go high. Beyond high, high plus, you get sort of diminishing returns. So if you're really concerned about light quality, like if you're in a space where it's really limited on light, going up to high plus or high will probably have a bigger impact. Renderings tend to be easier to render and require less high quality and less demanding settings when you have a lot of light. So exterior renderings in general are almost always easier to do. Interior renderings, especially where you're limited on light, those are going to be the ones that are going to be a little bit trickier to get set up, a little bit trickier to sort of balance the light and make them sort of clean and beautiful. So everything else here we're going to sort of ignore. There's a denoiser. This doesn't really matter too much. It's more for the progressive render than it is for the final renderer here. So next we have camera. So the standard configuration is just to use the standard camera, although there are, well, these other cameras are actually for basically for VR. So if you wanted to make a environment that you can look around in 360 degrees, that's how you can do that. Under exposure, so this is essentially the EV value is how exposed the image is. So adjusting this will adjust your exposure. White balance here, which can be set to auto, which is generally speaking a good idea, is essentially if your image is too blue or too orange, white balance will help balance that so you can make pure white in your scene actually pure white and not off-white in one of those directions. Depth of field we're not going to be messing with, but that's essentially replicating the effects of a DSLR camera where you might have something in focus and other things out of focus. And then there's some other effects here that I'm just going to pass by. Render output. So this actually is very important. So this is the pixels that you were rendering. Again, for starting in the process and doing tests, leaving it at 800 by 450 is fine. However, I always suggest going to match viewport under the custom aspect ratio. because what that'll do is ensure that the screen that you see in front of you in Rhino is the same proportions to the screen that you are rendering, so there's no difference there. So in general, always leave it on match viewport. That's almost always a good idea. When I'm using tests, I typically do 1000 by whatever. It'll update the height to basically the proportions of your viewport. So in my case, I put 1000 and gave me 591. Doesn't really matter too much what the second number is. When you're doing your final render, what I'm recommending is set the width to 3400 and the height will be whatever it is. 3400 is simply 200 dpi for an 11 by 17 image. Multiply 17 by 200, you get 3400. And the height will be whatever it is. But for test, we do not need that many pixels. The more pixels you have, the longer it takes to render, the more time it takes to calculate. And it's pretty dramatic how much longer it will take the higher pixel count you get to. I don't know what the limit is here. The highest I think I've done is a 10,000 pixel wide image. I think I might have done 12 once. Those can take a really very long time. It does depend dramatically on your hardware and your rendering and about 1,000 other factors, but in general, 1,000 for test, 3,400 for this example for your final image. So you can set it up to automatically save when it completes. This is a nice thing if you're planning to, say, go to sleep when you start the rendering and you want to make sure it saves as soon as it's done. You just enable that and tell it where you want it to save. That's also useful if you're creating an animation, but we're not going to cover that today. The next tab, this is the environment tab. So this is what's illuminating your scene primarily in all directions. There's a few things we're really going to want to adjust here, specifically GI and background, but I'll come back to those after I've gone through just about everything else. So material override, this is a really useful one. Essentially, it allows you to override all the materials in your scene so that they are just a set color. What this is really useful for is when you're doing, say, testing out lighting scenarios or something like that. You don't necessarily need to have all these fancy materials that you've already applied. You're really more concerned with just the light quality. And this turning the material override on allows you to render significantly faster because it's not processing anything other than just the light on a gray material. So it's a really good idea to have that on initially when you're figuring out your lighting in the scheme. Swarm we're not going to cover. That's for, well, when setting up a render farm or something, which you're probably not doing. So on the right side here, we have the quality adjustments. Now, most of this you do not need to really understand almost anything about. Because as we adjust the quality toggles here, you can see it's actually making adjustments to the quality numbers that you see on the right. So it will automatically adjust most of the things here for you. So you don't need to pay too much attention. Global illumination parameters, so we can actually even make these bigger. In general, again, you don't need to adjust many of these. There is a sort of primary raise engine and a secondary raise engine. By default, I believe this is the default, which is using brute force and light cache. All you need to know is those are good settings. These are things that you can adjust if you want to use different ways of calculating light that may be faster or slower or more accurate or other things. Ambient occlusion is a useful setting that basically adds contact shadows to your scene. This can be a thing that you can add in. I will talk about it at a later time. We have volumetric environment, so if you want to add in fog or things like that, that's where you could do that. Missed camera parameters. So this gives you a bit more advanced camera control. So if you're used to using a DSLR camera and you're familiar with ISO or aperture or film speed, you can independently control those factors instead of using wherever it was under camera, the EV value. In fact, if you see here, as I adjust these, it actually adjusts this EV value. In general, film sensitivity, your ISO, the higher the number, the brighter your image will be. And that's mostly what the exposure value is going to adjust. If you're not dealing with depth of field, that's really the only number you need to deal with. If you are dealing with depth of field, which again, for this assignment, you don't really need to, F number or aperture determines depth of field, with lower numbers creating more depth and higher numbers creating less. But we're not really covering that today anyway. So gonna skip over contours and denoiser and configuration as, and I'm not sure if contours exist in the previous version of Rhino or if this is new to Rhino 4. Anyways, so that's the basic general settings. Ooh, that's a lot. So the first thing we're going to do is what's always good practice when doing a rendering, which is we need to set up a camera. So I have this model here. You can set up either a clipping plane section perspective, which V-Ray will recognize a clipping plane. So if we just create a clipping plane, I'm just going to create a vertical one and snap it to my pool here. V-Ray will recognize this by default. And if you click on the object properties, which put that back, you can see there's a new tab here that is V-Ray. And this is where you can make some adjustments to it. So if you are interested in setting up a clipping plane for a section perspective render, you could do an image something like this. Again, this sort of gives you, oops, didn't mean to do that. Can give you a nice idea of the drop off. So if you see here, this is a flat surface. It's that much deeper into the ground or exposed there, where here it's basically flat. So our site really isn't very flat when you look at it across the entire length of it. I am not going to do a clipping plane render, although you certainly can. I think they're very valid renders to do. What I am going to do is set up a perspective, and I'm specifically going to go and do a 2-point perspective, which will shift your camera as it adjusts. I'm now going to open up my other views, and in the view that I am intending to adjust here, I'm going to move this guy now. I'm going to go to Set Camera and go to Show Camera. You can also do this by hitting F6 on your keyboard. Either way works. And that makes your camera into a physical object. That's something I've mentioned before, but it's a really useful thing to have when setting up for a rendering. Specifically, what I'm going to do is actually just take the base point of my camera and snap it to the ground. The reason being is I'm now going to elevate my camera 5'5" above the ground so that it is at eye height of a 6-foot tall person. If I right click on the orbit tool up here, that allows me to adjust my camera. So, oops. And I shifted things unfortunately, but that's all right. I'm just going to snap back to the ground and lift it up again. But basically by doing this, I'm ensuring that I'm not looking up or down, I'm just looking straight out. If we look at the camera and the elevation, this point actually shouldn't be lower. We should try to make that also aligned. I'm just going to, for the sake of the demo, just kind of get it approximate. And that will ensure that our horizon line is running across the center of the image, which is what we want and will be useful for composing later. Because essentially what you can do then is just align all the eyes of the people if you're using a perspective like this, and people just kind of fall into place. So once you have a view that you like, you can go to right-click, Set Views, and go to Name Views, and save this as something. So this Name Views tab that will come up, you can actually just put up in the corner here. I find it useful to keep that guy around. Of course, I'm going to get rid of the Help tool because I don't need that. I'm going to get rid of notifications because I don't need that. And I'm going to get rid of my libraries because I don't need that. So I just have my properties, layers, materials I'm actually not going to need. That is useful for Thea, but for V-Ray, it handles materials separately. So I just want to have properties, layers, and name views. And this allows me to select between views, and it will automatically snap back to exactly where it is. Anytime you're doing renders, it is really important to make sure you save the view, because oftentimes you're going to have to come back and re-render things or make adjustments. And if the view is exactly the same perspective, making those adjustments means that you don't have to redo your Photoshop file, because everything should just drop into place exactly as it was. So it's a really important thing to make sure you name all of your views and save them ahead of time. Okay. So next, let's make this big again. V-Ray can use the same sun and sky system that we have in Rhino. So I'm going to turn both of those on, and then I can go to the sun. So if you don't have this panel yet, just type in lights or sun. Either one will bring it up. And I can make sure I'm already located in Cincinnati, Ohio. Well, close enough. It's Frankfort, Kentucky, which is the closest city to us. This file I think was already located anyways, but And it can set any time of day. Now we don't see any shadows right now, but what we can do is if we right click in the upper left hand corner, we can change the viewport mode to V-Ray Interactive. Now this may be, it's going to take a second to process. Well, it's very overexposed right now, but that's in part because I just turned on the sun and we also have another light source in our scene. So we'll want to make some adjustments for this to not look completely crazy. I'm just going to go back to the standard shaded view again, just to sort of calm everything down because it does start winding up your computer. It's definitely a good thing to keep in mind. Rendering with V-Ray or Thea or any software is about the most intensive thing you can do on a computer. So make sure you are not rendering on your bed or something where you're sitting your computer on insulating material. You want to keep it as cool as possible. I've even put a large fan facing a laptop before, or even just the desk fan or something like that, and it can make a tremendous help in keeping your computer cool, which ultimately will keep your computer lasting longer. Overheating is really not good for electronics, and the computer will try to save itself by slowing itself down and also slowing the rendering down if it gets too hot. So get some good airflow on it. If nothing else, putting it on a solid surface or even elevating it off that solid surface. I have a couple little wooden blocks that I put beneath the laptop that really help keep it cool because they allow just natural convection of airflow around the laptop. Okay, so as I mentioned, we're gonna have to make some changes. So the first is we're gonna go to the little settings panel here, which is the gear symbol that you see here, and we're gonna go down to environment. By default, V-Ray has this sort of texture as an environment. So if you did a render without making any adjustments or turning the sun on, in fact, let's do that real quick. I'm gonna just turn my sun off again. What we should see is, and give it a second, still overexposed, but you can see here, we see light coming in from all around in this sort of weird shape that looks something like this. It's supposed to represent sort of abstract scene lighting that you might have in a photography lab or something, but not really appropriate for architecture. Also, we are overexposed, as you can see. So we could go to the camera and adjust the EV value. What you'll see is as you adjust it, so higher numbers are going to have less exposure on the EV value. Now, I personally prefer to use the advanced camera because it's a little bit more fine-grained control than the EV value, that it's really hard to get exact numbers as you want them to be. So as you move this thing around, it's kind of finicky. Whereas here you have a bit more fine-grained control because you're dealing with much larger numbers in the case of ISO. Anyways, so we're going to go down to the environmental tab. Here, if we click the little checkerboard, we can see what we have applied. And I believe I was in so this is the background. So I actually want to go and click on that. It'll bring up this little tab here. If I click on the advanced settings, actually I don't need to do that. I think I just click right here. I can switch this to the sky setting. And what that'll do is instead of using that random pattern, it's going to use a sky generated based on the Rhino sun. So I'm going to go back and actually do the same thing for GI and set the two text to sky. And just leave it as the default. Whatever it is fine. But now basically we have the sun and the sky affecting our scene and not whatever else was there. We actually might even be able to turn the background off. Well, no, so that's personal preference. So if you turn off the background, it'll just be black. We might be able to make it white if we do this. Well, it's not white, but it's grayish now. So, but if we enable this, it'll have a generated sky. We can't quite see it because it's overexposed. So we would want to go back to camera again, and again, we could adjust the EV value until we get this to be something that we like. Now it is very blue right now. Let's look at what we have as our sun settings. So our sun actually isn't even on. There we go. Now our sun's on. You can see we're very overexposed right now. So when we just had that blue light, that was because we were just bringing in the light from the environment and not direct light from the sun. And the environmental light, since the sun is passing through all the gaseous environment that we have, changes the color of the sky, and that color of the sky is giving us that sort of blue tone onto the ground. Now we are still very overexposed, so we'll want to continue adjusting the EV value. And maybe something like that. Okay, so that's going to be kind of the basics for getting your lighting set up. And you can see here the benefit of being able to get real-time feedback. So I'm actually going to go back to my shaded mode, and I'm going to do this the other way. So I'm going to close all these and go up to the top, and I'm going to leave interactive on and just hit the render button. And all that's going to do is just bring me, or give me, a separate window here that will allow me to essentially continue rendering, but keep V-Ray doing whatever it is. Not V-Ray, but keep Rhino doing the standard window. Sorry, there's a lot of things on the screen at once. As with many programs, V-Ray is easier with multiple monitors, but I can't show you multiple monitors at once. So I'm just going to put that down. You can see here the exposure is looking pretty good. Let's open up and go down to white balance. So if we click this, see if there's going to be any difference. It's not actually allowing us to click it right now. I guess it doesn't want us to click it, or only can be used for production rendering, so it can't be used in this version anyways. But if we were to make adjustments to white balance, I think we'll have to start again. We can't do the auto version, but we might be able to do it by our hand. If we make this oranger, you can see the image gets bluer. And you could think of it as essentially like filtering out light. So if it becomes bluer, and actually the best way of doing this is the sort of Kelvin scale down here. It's the normal scale for the color of light. Higher values tend to be bluer, and lower values tend to be warmer. So normal incandescent light is around 2700K to 3000K. Daylight is around 5000K. But basically, if you're finding your image is too blue, or if it's too red, go to the white balance and you can adjust it here. Of course, you can use the auto setting, but just not in this interactive mode. Okay. So you may be able to hear my computer making a bunch of noise in the background, and that's just because it's running, trying to keep cool as best as it possibly can. So it's running all the fans at their near top speed. Okay, so I'm going to stop this, and now we're going to talk about materials. So this panel on the side here is the V-Ray material library, and there's a whole bunch of standard materials in here that are maybe an okay start. I have put together a set of materials for you guys to use in this assignment, and that set looks something like this. Basically what we have here is a couple essentially black and white images that we're going to use to create a screen material. We have this, which we're going to use to create a water material. Several versions of brick that are actually just lines, and these are images that I had created in Illustrator. My preview doesn't want to work right now, of course, but you can see them fairly well here. And one tile texture that is also something that I had created. This was for actually a particular project that I was working on, where we had spec'd a particular tile and wanted to see what it looked like in the space. So the company that produced the tile had samples of individual tiles that I was able to essentially patch together in Illustrator to create a tileable, in this case tileable means something different, but a texture that is repeatable that we can apply to our scene. So in this case, as with any tile or any sort of texture, it's a good idea to get a sense of how big you think this thing is. So each of these tiles could be any real size, but it seems to be about twice as long as it is wide. So if we look here and let's just say that it's 2 feet wide and 4 feet long, that means that the base of this texture is 8 feet by 12 feet, just based on the fact that we have 3 of these that are 4 feet long and 4 of these that are 2 feet long. And that's a good thing to keep in mind, because we're going to have to scale this texture to make it look appropriate when we apply it. So again, we could use any of these here, and there's a lot of them in here. I tend to not like these for a couple reasons. One, most of them probably fairly well made, and some of them can be a great starting off point. But if you only use these, it's hard to understand how textures are made. Whereas if you make your own textures, you can understand the parameters that control them and give you more control in the future to actually make adjustments and not just rely on someone else's pre-made things. The other problem with pre-made textures are you never know exactly what they were made for. So some of these might be made for architectural renderings or interior design where we're not necessarily, we're looking at things in a distance. But V-Ray is also used for product designers who might be looking at, say, a cup or a mug, where they're actually looking at this thing from 3 inches away. The fidelity of a texture you need for something you're looking at that may be 3 or 6 inches away is much higher than the fidelity of a texture that you need for something that is part of a whole scene. So because we don't know exactly what these were made for, we might end up with a lot more, say, quality or a lot more, file size in the assets alone than what we necessarily want, just because we're using someone else's things and we don't know why they were made. Again, these can be a fine starting point, but I think it's good to also make your own things from time to time. So all the textures I'm going to make are going to be ones that I make myself, but I'm always going to bring these up. The metals here are particularly ones that maybe aren't worth making because metals are a very particular type of thing to make. And they have a very specific reflectivity, very specific way in which light interacts with those materials. So using someone else's made metals, that might be a good idea, especially if you're making 24 karat gold, for example. Anyways, so for textures, we have a texture panel on the far left. Since I don't have any made, it's going to ask me to make a texture. I always start with the generic. Just click that, it'll create a texture. So under generic, it has a number of different layers. The first is diffuse. Diffuse you can think of as the color. So if we adjust this and make it red, you can see that the material is now red. This is also where you can put in textures. So if we wanted to add in that tile texture, this is where we do that. V-Ray also has reflectivity. So by default, it's currently turned off or turned to black. If we make it all the way white, you can see it becomes a very reflective surface. There's also refractivity or refraction, and that's the way light moves through a material. Reflection is light bouncing off, refraction is light moving through. So if we make the refraction into its highest value, which V-Ray, as with many rendering programs, works on a value scale of black to white. And the reason being because you can replace these with black and white images the same way you might use black and white images as a layer mask in Photoshop. It's the same exact process. It's just using black and white to calculate values between 0 and 1. So at white, you've set a value of 1 for the refraction, so it's fully refractive. So I'm going to leave this down at black to keep it opaque. There's also opacity, which is separate. So if we turn on opacity, which I think if we just lower the value, you can see basically light isn't really affected as it moves through it. So when light moves through a refraction, the light is actually going to change angle the same way that light changes angle through glass or water. With opacity, it just changes the opacity of the material, plain and simple. For glass in a scene, I actually find that the opacity is actually a slower option than using refraction. But there's probably a lot of renderers have a architectural glass or a thin glass material that can also be faster. And I have to search through this library to see if it exists. I'm going to close that up. Next, we have bump. So bump is essentially the three-dimensional quality of the surface. So most surfaces aren't perfectly flat, so they have some degree of bumpiness to them, and the bump allows you to simulate that. Now, a bump only simulates it in a sort of 2D fashion. It doesn't actually change the three-dimensional quality of the surface. It just changes the way the light behaves at the surface to make it look three-dimensional. There is another way to do essentially the same thing, which is called displacement mapping, where that actually will, at the time of render, make your surface three-dimensional. That can be useful if you are, say, zooming in on a brick wall or a stone wall where you really want to have a really high-quality three-dimensional stone to it. But for most rendering, it's not necessary, and it does tend to be slower and tend to be a bit trickier and finickier to get set up. So those are the sort of basic materials that we have. The can be overridden thing here at the bottom, that will be useful later on. So if you end up using the material override to set up lighting, one thing that's often nice to not override is a glass material because you still want light to come into your building. So let's make a glass material. So I don't need this to be, it's actually not going to matter what color I'm going to set it, but I'm just going to make it black for now. I'm going to open up my refraction and set that to white, and open up the reflection and set that to white. And actually, At these default values, this makes what I would call perfect glass, which means it has no impurities to it. It is perfectly smooth, and it is essentially molecularly perfect. Glass like this doesn't really exist in real life, but for most of our purposes, it'll work fine. If we right-click on the name, we can rename this into glass. Now, this will work really well on glass that is three-dimensional. So if you apply this glass to a thin material, such as a surface that doesn't have any actual three-dimensionality to it, is not a closed polysurface or a closed extrusion, because it is a material that is intended to have a refractive quality where light moves through it, it goes into that material but never actually comes out again because it only has one surface to go through. So oftentimes if you see a render and when you're doing a render, the glass appears to be essentially pitch black, that's probably why. It's not being read as a solid. So light is entering, but essentially refracts infinitely until it is complete blackness. So in that case, let's see if they happen to have a glass in here. So fake glass is probably the one to use. So we'll add, well, I don't know what I clicked on there. I did add to selection. I didn't have anything selected, so that's okay. But I brought in a fake glass. We could open this up and see how it's made. But I believe if we start applying this, it'll probably work a bit better. There's also some other glasses in here, simple glass, crystal glass. They have so many options these days. Glass window neutral. There's a standard glass. So the standard glass here, which I brought in, is black for some reason. I'm just going to delete that real quick. But you can see that it actually has a bit of a green tint to it. So real glass, we made what I call perfect glass. Real glass, which this one doesn't seem to be working. Well, either way. Real glass actually has minerality to it that actually changes the way the color of light as it moves through. So if you've ever looked at the edge of a piece of glass, oftentimes it will look green. We can simulate that by adding the smallest amount of color to the refraction color. So we could pick this sort of greenish tint, and literally just moving it even just that much will have a huge impact. Doesn't look like much, but it really does do have a big impact. To apply materials, the best way to do it is to apply to layers. So if you're already built your model in layers, this will be a pretty easy process for you. So I'm just going to apply it to glass. Now you can see here in this sort of standard view, which I have the shaded view up, we don't get a preview of textures. We can, however, change that. So if I just go to my display options and scroll down to where it says color usage and go to rendering material, it will now preview those rendering materials. So you can see that glass is transparent. I also apparently moved this wall. That is not where that wall is in the actual Barcelona pavilion. So I'm just going to move it back because I don't remember where it goes. And I don't want to undo everything right now, so I'm just going to put it right there. Sorry, Mies van der Rohe, for moving your wall. It's definitely not right. I'll move it once more. Again, not the actual place, but that'll be close enough for now. This is just a demo anyways. So we've made one material. Let's go ahead and make another. So let's make some water. In fact, I'm going to do it a very similar way. So I can click up here and do another generic material. And in this case, I'm just going to open up refraction and reflection and set them both to white again. And I'm going to add a bump now. So the bump, you can use the bump that I provided. So I'm going to go to click on the little checkerboard. So anytime you click on a checkerboard, it's a place where you can assign something else. Typically, it is a texture, although there's lots of other things. So a lot of these other options you see here are essentially V-Ray generated textures. So there is a water that V-Ray can generate. We could try that and see what happens. Now it's giving us a preview of that water texture. So we could then, of course, rename this. And now we can apply to layer, and I believe I have a water layer in here, which now has taken on that texture. Now we can't really see anything because it's not really previewing what that looks like. We just get to see that it's now transparent. Sorry, this menu takes up so much space. Make that a bit smaller. But that's mostly what we need to do. Now this water currently has, well, glass-like properties. It has no sort of color to it. So we could, similar as we did with the glass, actually add a little bit of color. And maybe that'll be enough. We'll have to see in the rendering because the depth of the material makes a big difference. But that should work fairly well. The reflectivity and the refraction value, which is the IOR value, index of refraction, is actually going to be pretty close to 1.6 for water, so we can leave that alone. I think water actually might be 1.55, but it's really not going to make a difference. And that should look fairly good. Now, when we render, we'll have to adjust the scale of it because textures that we make here inherently don't have a scale, whereas we have a real world scale we want to set things to, but we'll handle that a little bit later. The other way to do this would be, instead of adding in that water texture as a bump map, as we did, we could, so here we can basically adjust a bunch of things. So this yellowish image essentially is a generated wave map. So if we increase the amount of wind, we can make the waves more affected by that wind. We can do the wind magnitude, the choppiness, a bunch of different things to adjust our water texture that is sort of generated. And this is probably a pretty nice way of doing it. Just to show you the other way of doing it is, instead of applying that bump map there, we could just go back, click this, and go to bitmap. And I'll have to navigate to the loop. Okay, so I have this texture that I've provided for you guys called the Nomerata Pool Water Displace, and it's essentially the same thing that Vera is just generating. And we can see here it's a different scale, but it's ultimately doing really the same thing. I'm just going to leave that for now. Next, we're going to continue down the line and continue making a few more materials. So you can also go down here and do new material generic, and let's make that tile material. So in this case, let's rename this to tile, and I'm going to apply to layer, and I believe it is my travertine base that I want to apply to. And in this case, going to go to the texture slot under diffuse and click on bitmap and navigate to my texture. And I want to use the one that says diffuse, so that's your basic color. Now you can see it has applied. Now the scale I actually already had set, but I'm going to show you how to set the scale. So with any object selected, I'm going to hide this little menu for a second. So the scale of objects actually isn't set by Ray, it's set by Rhino. So if we go to properties, under we have a few tabs up here. So we want to go to the texture mapping tab, which is this guy here. In here, the best texture mapping option, in my opinion, is going to be the apply box mapping. This is really the best one to use for architectural and interior design purposes, as most materials tend to apply really well this way. There's a bunch of other options, but for most 95% of cases, I find this one to be the best. And essentially, it just wants you to draw out a box. You can see here, you start drawing out. I'm going to hit 3 points so I can align to my object that's not on the same grid. And I shouldn't have snapped. Basically, with each time you draw, I'm just going to do this again, actually. And just going to hit 3 point. So basically, it's going to ask you for an input of dimensions. So if I know that I want this texture to be 8 foot by 12 foot, and I'm just going to set the height to be 8 foot, it's essentially going to stretch and remap that texture to be those dimensions. Now afterwards I can always adjust it here. So if I wanted to say, well, maybe I wanted the height to be actually larger, or I wanted to stretch it even further, these dimensions right here will allow you to do that. You can also add a rotation in down here under UVW rotation. But I happen to know that that was the size that I wanted, so I'm just going to leave it. And just to see how things are going, let's turn on V-Ray Interactive one more time. So take a second to process. And we're not seeing any textures, so I might have material override on. In fact, I think I do. So I'm just going to go back to shaded and open up my V-Ray asset editor and go down to settings. And material override is indeed on, so I want to turn that off. Now, material override, as I said, is really useful when you're setting up the render for the first time to get lighting to work properly. But once you start adjusting textures, you're really going to want to have more control than that. So I just open it up in the standard renderer frame buffer that you see here. And we're starting to get an idea. Looks like we are still, I'd say, a good bit overexposed. Let's try that in, see how different it looks in the V-Ray Interactive. So we're starting to see things. It is definitely quite bright, so we would want to come in and continue adjusting that exposure value. Let's try 13.4. Anyways, just continue adjusting until it starts to look better for you. And I'm going to just go out of wireframe's fine, but I'm going to go shaded if I can click it. But let's go back to that texture. So now that we've applied it, let's do a few things to make this texture a bit more realistic. So all materials have reflective qualities to them. So leaving this black is, let's just say, pretty unrealistic. If you see something in real life, it is reflective. There's that one material that is perfect black, or I can't remember what it's called, that essentially has the lowest reflectivity of any material, and it appears nearly pitch black. But this is kind of a misnomer because it says it's not reflective, but really it is still. So I'm going to add some reflection to it. You can see here tile probably maybe isn't quite as shiny as that. Now there's a glossiness factor. So if we turn this glossiness factor down, we can't really see because it's kind of hard to tell, but basically it's how smooth the reflection is. So a mirror would have 100% glossiness, whereas a normal material on your desk or something is going to be not nearly as glossy and sort of more of a rough reflection. In fact, renderers tend to use those terms of either glossiness or roughness, which are actually opposites of each other. So in Thea, for example, you adjust the roughness of a texture, or in V-Ray, you adjust the glossiness. Ever so slight changes, they do the same thing. They're just literally quite opposites of each other. So for the glossiness, instead of just doing an arbitrary number, I'm actually going to apply a texture again. And I have given a roughness texture. Now, this roughness texture is actually going to do the opposite of what we want, because roughness is opposite of glossiness. So we want to go in and do a color manipulation, and we're going to invert the texture. The reason being is we want our texture, or we want our material to be fairly reflective, fairly glossy. It's tile, it's a pretty smooth surface. So values that are closer to the white are going to be more glossy, more reflective. Values that are closer to black, as it was originally, are going to be less so. Again, it's the opposite for what Thea does, so that's why we have a texture here that is the inversion of that. But all we have to do is just invert it, and it'll work fine. You can see here, it's kind of hard to see in this image. I'm not sure if we can make this image bigger or not. There we go. Essentially, it's a little bit less glossy where the grout is between the tiles, but otherwise the surface of the tile has some subtle variation in it, but is pretty consistent for the most part. So that will give us a little bit more realistic looking. And this glossiness number here, I believe, will still, doesn't actually seem to be changing anything, so I guess it's just using the value of the texture itself. Again, a difference between this and Thea, where the multiplier will then affect the texture. The next thing we're going to do is we're actually going to add in a bump, similar to what we did for water. But in this case, we're going to go to bitmap again and use the bump. Now this is the same for both programs. It looks like this. That's fine. Go back to our tile. You can see here we now have a very intense bump that we see on that tile, so we're probably going to turn the value down quite a bit. And let's do another interactive test render. So if we look here, we can see the tile's starting to look pretty realistic. I'd say the bump is still too aggressive, which is actually surprising to me that it's still too aggressive. So let's add another decimal point in there. Now we have to tab out of this to make it take effect. That's looking a good bit better though. And we can see here the reflections are sort of being adjusted by the tile, so that the column or whatever the element is at the building here is sort of scattering its reflection. So this is looking pretty realistic, I'd say. And that's kind of the basic construction of any material. You're typically going to have, for the best materials, you're typically going to have several layers. I think the minimums are that you're going to have a diffuse of some sort. You're going to have something that defines the glossiness, which is what we added in, not in refraction, but in reflection. And you're going to have a bump map that defines the three-dimensional quality to this. I actually, looking at this, think we could even take that down just a little bit more. Let's try 3. Now, let's talk about this guy for a minute. So this is the frame buffer, and it has a few options. I believe this one actually looks slightly different than the version in 3.0, but the same options are available. So there should be a region render, which will be, I believe, up here somewhere. It'll look something like a box. I think it's a red box in that version. And basically, it allows you to select a particular area of the image, and that's what it will focus on rendering. So it'll clean this up before it cleans anything else up. So if you want to just test a particular texture and you're not worried about rendering the entire image, region render allows you to do that. I'll turn it off now. And I'm going to stop the rendering process. Okay, so we've created several materials. Let's create a couple more. So we're going to create a, let's do an interesting material here, something for a screen wall of some sort. So I'm just going to create a quick little plane. Actually, I'm going to do a vertical plane. I just want a two-dimensional surface, like you see here. And we're going to create another new material, same way, materials, generic, and do rename screen. Now in this case, because I didn't make a separate layer for this guy, I'm actually just going to right click and apply to selection. Although usually not the way I recommend doing things, because I'm just doing a test right now. That is the way I'm going to apply this texture. So what we need to do is we're going to actually define the opacity of this texture with a texture itself, or define the opacity of its material, I should say. So we're going to click on the little checkerboard as usual and apply a bitmap as usual. Now I've supplied a couple different of these black and white images, the circles and the grate. I'm just going to use this grate here. And if we look at this screen now, we can see that we've essentially just cut holes in it. We use this texture, so anything that's black will be completely transparent, anything that's white will be completely opaque. Again, very much like using Photoshop layer masks, it's really the exact same thing. So we can make a sort of realistic looking screen texture. I am going to apply box mapping to this and make it something smaller. Let's say 1 foot, 1 foot, and 1 foot. So now it's a much smaller texture, giving a little bit more realism to it. Next, let's go in and give this some reflective quality and make it a little bit less glossy, make it a little bit more metal looking. We could increase the metalness, which does exactly what it says. It makes it very metal looking. Wonder. So looks like you can have metalness independent of the reflection. So you can maybe make some very unique materials on how much of those two things you add in. The surface controllers using glossiness. Oh, so we can actually adjust this to use roughness. Oh, that's cool. So if you don't want to have to invert the texture, you can just do it this way. Now in this case, I don't think I have a bitmap for this. No. All right, so I found that for whatever reason, if I have the metalness all the way up and the reflection all the way down, no matter what I do to the roughness, it doesn't actually change that reflection. That might be a glitch in the current version or just something weird, so I'm just going to turn the reflection quality back up because it seems to allow that roughness to now take more of an effect. So in this case, I actually went in and instead of selecting bitmap, I went down to a noise map. I'm going to go to noise map B, and essentially this just allows you to create a irregular random pattern of variation, and you can kind of adjust these things, make some different qualities to them. But essentially, it just breaks up the surface so it's not quite as perfectly consistently refractive. I am now going to close out that and add in a bump map, because you might have seen there is a separate bitmap here that is this guy. So just think of this as a grayscale image that defines the height of that texture. So if we apply that, and again go back, we should start to see this as really starting to look like a very three-dimensional texture. Again, to start seeing what that really looks like, we're going to go turn on interactive render. So you can kind of see here, make this a little bit bigger, it's starting to have a three-dimensional look to it, even though it's really a two-dimensional material. So we could, decrease the bump, which will decrease the effect of that three-dimensional quality to it, the sort of three-dimensional shading that's happening, and find a sort of middle ground that we like. But this is a great way to create screen textures. When you're looking for something to give your model a degree of transparency, but isn't necessarily something where you want to model a whole screen wall. I mean, you could model this screen in Rhino. It would probably take you a little longer. And the other downside is, geometry-wise, this is a very simple plane, whereas modeling this could be very complex. So you can use really any black and white image to define transparency. So you can create your own patterns. Any pattern you create in Photoshop or Illustrator that's black and white, you can use to define a screen. So the two I've given you are this and the just circle hole pattern, which is just a common perforated hole pattern that you might use. Okay, let's look at the water. I don't think we ever checked that. Let's see how that ended up looking. Start the interactive render again. Again, I'm gonna make this bigger. You can see here the water is quite choppy, quite intense looking. I'm going to go ahead and see what the default water looks like. I can just drag that in, and we'll apply that to the same layer. So it looks like the V-Ray default water could be a good option and has some color to it. So it's built basically the same way. It might have a little bit more adjustments to the refraction. It has a fog color applied, which gives it that extra sort of greenish tint. And it is using a bump map. It has two bump maps. So this bump map probably has the water texture applied, or just a noise map, actually. Interesting. Yeah, there's so many textures in here that I'm not sure how V-Ray made each of them. But in this case, we could replace this with the same bump map that I provided, just so we can be consistent and see how that changes things. It looks like it might be a bit more aggressive in the noise. So we can go back to that texture and we could pull that bump down, lower the effect of it, make the waves a little bit calmer. Something like that. It's a really calm looking pool now. So you see this line in the ground there. That's actually the ground. I didn't bother cutting the ground when I placed the model in here. So that's actually the ground coming up through the water that we're seeing there, which is just kind of funny to see. So, you want to be careful when modeling that you take those things into account. Okay, so that's going to cover most of the basics of material creation. I think there's a couple other things I want to talk about. So pause this. And so something that V-Ray can do that Thea can't, which I think is a really useful thing, is when doing a clipping plane, which both programs can do clipping planes and render them properly, which is really fantastic. It's actually a relatively new feature in comparison to these rendering engines to be able to do that. In the past, you would actually have to actually go in and do a Boolean operation to remove half the building and delete it in order to render it properly, which always was a big hassle. So the fact that it handles clipping planes now is pretty great. But what I'm going to do is, so I have a clipping plane set up. Now, if we just start rendering, it should render just fine. It will be listed under this sort of box here, which are your V-Ray specific assets. And we can see here, we can turn it off. So it's just called Clipper, on and off, and that'll allow it to turn on and off as you would expect. There's a couple other settings. So if we want the building to act like the clipping plane is not there for the sake of sun coming into the building, we'd want to uncheck this. And that's a really important one because most of the time, illuminating your building by having a giant hole cut in it through a section and allowing that for the sun to come in doesn't really give you a realistic sense of what the lighting would be like in the space. So for the most part, you want to turn that off. The next is use object material. So oftentimes it's going to be better if we create a specific material so that we can actually create a consistent poche. So I'm just going to create a new material and just call it a, let's do color. And we can make this any color, so I'll just make it a nice orange for now. And now if we go back under the clipping plane, we can actually assign that color. We'll just do color. And now when we render, we can see it basically will fill in any solid object with that orange color, which is pretty great. Now, granted, it's doing something weird here. It's probably modeled weird. It will not handle not solid objects at all. So if you have a bunch of planes that are defining your walls and they aren't actually solids, it will not fill them in. So you want to actually make sure that you're using solids. But that's a really nice feature to be able to get the cut to show up that way. One other thing I was going to go over is the basic outputs that you can get. So if you click on this guy here where it says render elements, it's this sort of stack of planes that you see. There's a whole bunch of things that you can get as exports when you do your rendering. So the default is just going to be getting a color image that is your rendered image. But there's going to be some other things that are going to be really useful and some things I've specifically requested that you export. So the first is going to be material ID color. That's going to be an incredibly useful one. Essentially allows you to select individual materials just using the magic wand tool. And so you have to right click after you've created these once. So right click, and then you can add in Z depth. So this provides a black and white image that is based on the depth of the image. So you may want to set a I believe a far distance. So this is in units, model units, whatever you're working in. So in my case, feet. So that'll mean that it goes completely black 500 feet away. That might be a bit more than I need. I might set this to 300. I'm going to right click again. And I believe the other one I've suggested doing is going to be sample rate. And this essentially just gives you a color image. It's not really used for composing, but it tells you what parts of your image took a long time to render. So anything that is red is where it spent most of its time calculating. Anything that's blue, it calculated very quickly. So that's really good for figuring out what is working in your scene and what is taking a long time. Next is reflection. So there's a couple different reflections in here. And the one that I think is going to be most useful is just reflection, not raw reflection, but just reflection. And essentially, these are just all the reflections that happen in your scene. I believe this is all I've asked for. Yeah, there was one other thing I'd asked for, but it doesn't seem to exist in the current version of V-Ray, so I'll take that out of the assignment sheet, and that was alpha. It's not really necessary anyways, that's just sort of where the sky is. You can also use background, which does something quite similar. But these 4 will be fine. So I'm just going to, well, let's do a quick little test render again. I just want to make sure that my lighting is relatively okay. It seems pretty bright. So I might come back and continue adjusting this. So you can do it by camera, or again, you'll have more control if you go to advanced parameters. And maybe just take down, oops. Adjust the film sensitivity until you get it to be the exposure that you like. Let's try, okay, good enough. When you are ready to actually do your rendering, what you'll want to do is turn off interactive and turn off progressive, set it to high. We'll go down to render output and set this to be 3400. Because match perspective is on, it'll adjust both. And then we can just press the render button and it will start. Now you'll see here, this will take a good bit longer. It's going to run through a series of phases. You're going to have these little squares running across your screen. These are called buckets or render buckets, and they basically represent a single processing thread of your CPU. So depending on what CPU you have, you may have more or less of these. And essentially they're just going to run across the screen and calculate each little area. There is a follow me tool, which will allow you to pull the buckets into specific areas. So if you want to see what the water is looking like here, again, it might look slightly different for you, but it's still up here. It's just going to be, if you hover over, it should tell you the names, but the follow the mouse tool. It's not really necessary anyways, but it is kind of fun to have the little buckets follow you around. Yours will also, I don't know if the older versions have color buckets or not, but these are colored. It doesn't really make a difference. But it's just going to go through and render this thing, and it'll take a little bit of time. Okay, so this just finished. It took maybe 5 minutes or so. We can look through the layers now. So we have the RGB color. So I mentioned alpha before. It actually still exists. It's just not one you can turn off. So this is an alpha. It's just a black and white image where black is the background and white is solid objects. Next we have reflections. So these are just the reflections in the scene. Doesn't look like terribly much, but it's something we might use in post-production composing. We have material ID, which did not seem to work. Sample rate. So here I did notice that we had some issues where specifically where I had multiple materials in the same place. So I had my water here and the pool. The water of the pool and the ground overlapping. So because there were 2 materials, it was trying to figure out which one to actually render. And that was primarily the issues in both these cases. And in both cases, just because I actually didn't cut out a hole for the building to sit in, which is what I should have done in the first place. So it actually would have saved me time rendering. And the last is the Z depth pass, which you can see here. I set it to 300, which might not have been quite far enough. But essentially, it's anything that is white is closer to the camera, and it goes to black as it moves farther away from the camera. What's useful about this is we can use this as a selection tool in Photoshop. So if we want to, say, apply a blur based on depth, such as recreating what you might get out of a depth of field that you would get from a lens, we can do that. Or we can make, say, the background that's far off in the distance desaturated or a different color to really make our object in the foreground stand out better. And this gives you that ability. So it's a really useful tool. Now, material ID color, I was expecting to see a very colorful image here. So I have to check and see what the issue was. So after a little testing, for whatever reason, material ID color doesn't seem to work off the back. So there's something either wrong with it in this version or that I have to adjust. But adding in material random color does the same thing functionally. It just gives a random color for each of the materials you see in the scene. So you can see here we just have a flat image that is colored based on the materials. And this is, again, used for post-production to be able to select individual materials. So if, say, you render a whole scene and you realize that your tile is too light, you can select that tile and select all of that you have in the render and just use that selection to make adjustments to it or add another texture on top. It's really useful for basically making selections. And material ID versus material random color, either one will work. I will have to look up why the other one didn't work, but it doesn't matter. This one will work fine for you. It does the same thing. I'm not going to let this render all the way because I don't need to. We already had the one. I will make a separate video, though, for actually the composing process, which will be fairly quick and easy. But that is going to be the basics. So there are a few other things I was going to mention, and I'll probably do these in a separate video because there's a lot more complex things that, well, this video is already at an hour and 10 minutes, so there's a lot more complex things that I could cover, and I'll try to do a few more in the next video. So a good example is artificial lighting, which you can do with these lighting panels up here. In general, for your renders, I don't expect you to use much, if any at all, artificial light. I think in general, you should try to make most of your architecture focus on natural light and not focus on just using artificial light to illuminate your scene. So because of that, you shouldn't need to use it terribly much. There's some other interesting things you can do, such as image-based lighting, where instead of using the Rhino sun, you can use a spherical image of the sky called an HDRI, high dynamic range image, that is essentially an extremely detailed image that has a lot of color information, actually beyond the level of color information that your screen can display. And I don't remember how it compares to what the human eye can see, but a lot. That V-Ray and Thera and other rendering programs can use to actually inform lighting in the scene. So if there's a sun in the sky in that spherical image, it knows that that sun is casting light into your scene and contributing light and shadows and all those things. So I'll cover that in the sort of advanced one as well. Here is mostly your basic materials, setting up for clipping planes, things like that. Good things to keep in mind, always work off a named view. That's going to be huge for you. Make sure you name your textures as you go. As I said, there is a lot of existing textures here. Think of these as a starting point if you use them. A lot of these get used very often. I have seen several of these weathered bricks, for example, in a lot of projects. So just know that they are really commonly used because these are all sort of standards that everyone has in V-Ray. So it's really good to, whenever possible, make your own materials to make sure that your renderings are unique and not just looking like everyone else's. Okay, so with that, I think that's all. I'm just trying to make sure there's anything else that I want to cover in this first video real quick. I think that should be it, though. Again, there's so many more features in here that even in an advanced video, I'm not going to be able to cover, but this should be enough to get you started. I will post an advanced video. I'm also going to post a video on the Photoshop composing that you'll do and how to use the separate layers that we just exported. Those layers are going to be essentially the same as what we're going to get out of Thea, so it's just going to be one video for the two separate rendering engines. Okay? So with that, look out for the next video, and that'll be it for this one.